Welcome back to The Explainer, everyone. Today, we're diving straight into quantifying confidence, the architecture of intelligence. You know, behind almost every breakthrough AI model we see today, there's a hidden, honestly kind of invisible flaw right in its very foundation. So today, we're going to explore how the core architecture of machine intelligence might actually be masking a really critical weakness when it comes to trust, certainty, and data provenance. And, more importantly, we're going to look at how that exact problem is actively being solved. Let's get right into it.
Okay, you know the drill here. First, we start with months of rigorous dataset building, all that complex data scraping and setting up ETL pipelines. That flows directly into thousands of annotations, endless hours of human feedback, bounding boxes, the whole shebang. And ultimately, that leads to those high-stakes reviews, iterations, and deployment meetings. It's a massive, frankly exhausting chronological journey to get a system properly fine-tuned and off the ground. But as our source material points out today, the truly uncomfortable questions, they rarely appear at the beginning of this journey. When you're deep in the trenches of data collection, everyone's just focused on grinding through the work. Those foundational questions about architectural trust just aren't on the radar yet.
So let's dive into exactly what happens next. Section 1. The illusion of success. Perfect metrics, hidden flaws.
You've done the work, you've run the training cycles, and you deploy. And on paper, everything looks completely successful. Your validation curves are flattening out beautifully. The precision and recall on your holdout set are basically flawless. Every single number is mathematically validating all the sweat and tears you put into that pipeline. But actually, hit the brakes for a second. This is exactly where we need to take a step back, because those standard performance numbers, as great as they look, are creating a massive false sense of security right before the drop. They're masking something completely vital just beneath the surface.
Which brings us to Section 2, the uncomfortable question, shattering the illusion.
Because eventually, after all the hard work is done and the deployment metrics are being celebrated, someone in the room is going to ask the one question that just flips the entire paradigm. How much confidence do we actually have in the data behind this? Just let that sit for a second. Suddenly, in the blink of an eye, those perfect performance numbers stop being enough. Because getting high accuracy on a pristine test set, that cannot guarantee that the foundation of those answers is genuinely reliable out in the real world. That illusion of a perfect model gets completely shattered by this single vital question of data provenance.
Let's unpack why that happens in Section 3, the problem with static data and when uncertainty hides.
And this brilliantly illustrates the core flaw we're talking about. Traditional datasets are amazing at preserving raw information, but they completely fail at preserving confidence. On the left side here, we have expert judgment and verified signals. Really high-quality, trustworthy data. But on the right side, rushed submissions, highly uncertain guesses. The problem is that in traditional architectures, all of this gets completely flattened out. To the AI's loss function, a verified signal and a rushed guess look exactly the same. They're both treated as absolute truth with a 1.0 probability. Expert judgment gets mathematically flattened right alongside a rushed submission, creating a really fundamental flaw in how the model views the world.
Which leads us to a pretty alarming reality. The uncertainty never actually disappears. It simply becomes invisible. Hiding uncertainty beneath a clean-looking dataset doesn't magically fix the flaw. It just masks it from the very developers who literally need to know about it most. The raw data points survive, sure, but the human context, the doubt, the annotation variance, it's just gone. And what happens when uncertainty goes invisible? Well, models hallucinate confidently. They fail catastrophically in edge cases because they literally do not know what they don't know. You've built a system where the algorithm cannot distinguish the solid rock from the shifting sand.
But there is a totally different way to approach this. Section 4, building living systems and turning trust into a metric.
So the crucial point is we don't have to accept invisible uncertainty as the architectural standard. Codatta tackles this exact problem by rethinking data architecture from the ground up. Instead of flattening data into ones and zeros of absolute certainty, Codatta turns trust into something measurable. They use probabilistic labeling to identify exactly where confidence is strongest. They highlight precisely where ambiguity still exists by keeping that metadata attached to the inputs. And they pinpoint where additional validation is actively needed. By using this weighted approach, they make sure the vital nuance of human doubt isn't just erased from the training loop.
And honestly, it's a total paradigm shift. Datasets should not behave like static storage anymore. They should behave like living systems.
Think about what that actually means for your build. We need dynamic datasets where confidence weights can be continually updated, queried, and fed right into the neural network. For an AI to be truly reliable, the data feeding it has to act like a living organism that understands the strength of its own knowledge. It needs to know what it knows for a fact and what it's still kind of questioning, so the model learns doubt right alongside its intelligence.
So, as we wrap up, I want to leave you with this open loop to think about. Is your data acting as static storage, or is it a living system that understands its own confidence? It's absolutely the defining challenge for anyone building the intelligence architectures of the future. We've got to stop accepting invisible flaws and start demanding measurable, mathematically sound confidence. I really encourage you to go re-examine the data pipelines you rely on with this new perspective. Thank you so much for joining me for this explainer. Keep asking the hard questions about your data, and I'll catch you next time.